रिकॉर्डिंग स्टार्ट हो। चलो विजिबल है।
हाँ।
स्टार्ट कर लो। दीक्षा, हेलो हेलो।
अच्छा, कर दिया क्या स्टार्ट? सॉरी।
हाँ हाँ, कर दिया।
Good evening, sir. Today we are going to present a presentation on the topic temperature measurement. These are the group members: Aritri, Nishtha, Kumar, Vaibhav, and Kevin. Temperature measurement devices are instruments designed to detect and measure temperature changes in various environments. They are widely used in medical, industrial, and scientific applications to ensure accurate monitoring and control of temperature. These devices work on principles such as thermal expansion, resistance change, or electromagnetic radiation to convert temperature variations into measurable signs. Types of temperature measurement devices. There are mainly two types of temperature measurement devices. First is the contact based devices. These require physical contact with the object to measure its temperature. For example, thermocouples, resistance temperature detectors, RTDs, and thermistors. Second is the non contact based devices. These measure temperature from a distance by detecting infrared radiation emitted by the object. Some of the examples include infrared thermometers and thermal cameras. Contact based temperature sensors. A few examples of contact based temperature sensors are thermistors. These are devices which measure the temperature sensitive resistors with high accuracy in specific ranges. Thermocouples. These are made of two dissimilar metals that generate a voltage corresponding to temperature differences. RTDs. These are used. These use the temperature dependent resistance of materials like platinum to measure the temperature. Now we'll discuss about the construction of thermistors. Thermistors are made of ceramic or polymer materials whose resistance changes significantly with temperature. The construction process of thermistors include material selection, that is typically a mix of metal oxides such as manganese, nickel, or cobalt. Then the shaping of the material is done, and the material is shaped into small beads, discs, or rods. Then the thermistor is coated with a protective layer to ensure durability and prevent damage from environmental factors. Then the leads are attached for electrical connectivity, allowing integration into circuits. In the end, the thermistor is calibrated to ensure accurate resistance temperature mapping for its intended range. These features make thermistors highly sensitive and suitable for applications like medical temperature monitoring and HVAC systems. The thermistors are mainly classified into two types, that is NTC and PTC. NTC are the negative temperature coefficient thermistors. The main characteristic of these thermistors is that the resistance decreases as the temperature increases. These are used in temperature sensing, circuit protection, and in devices like digital thermometers. Second one, the positive temperature coefficient thermistors. The resistance increases as the temperature increases in these thermistors. The main application is that it is commonly used in overcurrent protection, heating elements, and de-icing equipments. Thank you.
Hi sir, my name is Vaibhav and we'll be looking at the working of different types of thermistors. So we'll firstly look at the NTC thermistor, which is the negative temperature coefficient thermistor. So it operates on the principle that the resistance decreases as the temperature increases. This behavior is due to the thermal energy in the material. At higher temperatures, more electrons gain sufficient energy to jump into the conduction band, increasing the number of charge carriers available to conduct electricity and thus lowering resistance. So at low temperatures, the thermistor has a high resistance because fewer charge carriers are available. This restricts the current flow, making it effective for detecting or controlling low temperature conditions. At high temperatures, the resistance drops significantly as the number of charge carriers increases, allowing more current to flow. This characteristic makes the NTC thermistors ideal for temperature sensing, control, and compensation in devices like thermometers, automotive sensors, and electronic circuits. So I just explained the working. So here is a simple circuit diagram which shows the working of the thermistor. So here we have a microammeter, here is a thermistor, and here we have the cell. So how it's used, the thermistor's resistance change is detected as a voltage change across the device when it's part of the circuit. The voltage difference is then interpreted by the circuit or a microcontroller as shown here, which calculates the exact temperature using calibration data. Now we look at the application of thermistors. So thermistors are used in various fields. Firstly, we look at the healthcare field. These are used in incubators to ensure precise temperature regulation in neonatal incubators. These are used in medical devices to measure patient body temperature and monitor temperature in equipment like MRI machines. These are used in HVAC systems to monitor and control temperature. HVAC systems is heating, ventilation, and air conditioning systems. These are used in thermometers, like digital thermometers for ac- measuring temperature accurately, and is used in healthcare, meteorology, and industrial settings. It is also used in food safety. That is, it is used in refrigerators, freezers, and ovens to monitor and maintain safe temperatures. It is also used in consumer electronics, such as smartphones and laptops, to monitor and regulate internal temperatures to avoid overheating. It is also used in charging systems to ensure safe battery charging by monitoring temperature. So this was my part. So we come to the non-contact based temperature sensors. These are of four types. First is infrared thermometers, that is IR thermometers. These use infrared technology to detect temperature from a distance. These are common in medical settings for measuring body temperature. Next, we come to thermal imaging cameras. These capture a full temperature map of the surface and is widely used in industrial inspection, surveillance, and medical diagnostics. Optical parameters. These measure temperature based on light emitted from a hot object. These are often used in high temperature measurements in industries like metallurgy. Then we come to fiber optic thermometers. These are suitable for environments with strong electromagnetic interference and is used in applications like power transformers and reactors. Thank you.
Good evening everyone. Today I'll be explaining construction of infrared thermometer. It is divided into two major parts, that is optical system and infrared detector. The infrared thermometers are non-contact devices that measures temperature by detecting infrared radiation emitted by the object. The construction is mainly consistent of lens, infrared sensor, signal processor, display, battery, laser points, and most important, the infrared detector. The lens focuses on the infrared radiation from the object onto the detector. The quality of the lens determines the accuracy of the measurement. The signal processor amplifies the process and electric signal from the detector and converts the raw signal into the temperature readings. The battery supplies power to the device for the application, and the laser point help to aim the thermometer accurately at the object. Now talking about the infrared detector, it amplifies the process and electrical signal from the detector and converts the typically thermophile or the pro-electric sensors into proportional electric radiation. It adjusts reading from accuracy across the range of temperatures. Next slide, please. Working of infrared thermometer, it describes how the device measures temperature by detecting the amount of infrared radiation emitted by an object. This is based on the principle that all objects emit IR radiation, that is the infrared radiation. The lens or the optical system recollects the infrared radiation and focuses onto the sensors. The sensor detects the intensity of the infrared radiation and converts into an electrical signal proportional to the temperature. And coming to the signal processing, the electrical signal is processed by internal electronics to account the factors by emmittability, that is ambient temperature and distance to spot ratio. By analyzing the intensity and wavelength of the infrared radiation, the thermometer can calculate the surface object and the temperature. The processed signal is displayed as temperature reading on the thermometer.
Next is application of infrared thermometers in healthcare. Non-contact temperature measurement reduces the risk of cross-infection by measuring body temperature without direct contact. Fever screening, widely used for rapid fever detection, especially during pandemics. Continuous monitoring, used in intensive care units, that is ICUs, for monitoring patient temperature without causing discomfort. We can use thermometers in home care, convenient for personal use, especially in fact infants and elderly patients. Environmental monitoring ensures the temperature of medical equipment, drug, and storage areas is within safe limits. Surgical settings monitor patient temperature during and after surgeries to prevent hypothermia or hyperthermia. Next slide. Comparison between contact and non-contact methods. Contact methods require physical contact with body or surface, whereas non-contact thermometers measure temperature from a distance using infrared. Talking about accuracy, generally more accurate are contact thermometers, whereas non-contact thermometers are slightly less accurate due to potential environmental interferences. High risk of cause infection is higher in contact thermometers, whereas in non-contact thermometers it is minimal. Convenience, less convenient are contact thermometers, and non-contact thermometers are highly convenient. Next slide. Emerging technologies in temperature measurement. Infrared thermometers measure temperature without physical contact, ideal of hazards or delicate environments. Smart sensors, advanced sensors with wireless connectivity provide real-time temperature data and analytics. Microcontrollers, embedded systems that are and regulate temperature for precise control. Next slide.
Aritri,
Now, coming to the quick quiz, what are the two main categories of temperature measurement method? That is non-contact based and contact based method. Next question. Give an example of a contact based temperature measurement device, the thermocouples or the thermistors. Third question. How does a thermocouple measure temperature? That is, by measuring the voltage generated at the junction of two metals when exposed to the heat. Fourth question. In what industries are thermocouples commonly used? It is commonly used in industries for manufacturing, HVAC, and automotive for temperature measuring. Fifth question. What is key benefit of non-contact temperature measurement? It allows temperature measurement from a distance without touching the object. And last question, what is the main component in an infrared thermometer that collect radiation? That is the optical system which include lenses and filters. That's all from my side.
Here we demonstrate the usage of a non-contact infrared thermometer. The device ensures accurate temperature readings from a safe distance of 1 to 2 inches from the forehead, making it ideal for quick and hygienic screenings in busy settings like hospitals. This video illustrates its simplicity and efficiency in operation.
can take temperature readings for both a surface object or body. So to switch between the two, you just press the set button. Now let's take a look at the thermometer settings. To get to the settings, you'll press the set button to add. This thermometer features a 3-color lit display. Green if there is not a fever present and a smiley face, an orangey yellow or red if there is a temperature present and a frowny face, red for a high temperature. This thermometer does feature an automatic shutoff. That thermometer is held 1 to 2 inches from the forehead for an accurate reading. This thermometer also stores temperature readings up to 15 readings. So to access those readings, you just use the arrow buttons on the side of the thermometer. The infrared forehead thermometer from Sanjmart.
This case study highlights the impact of implementing infrared thermometers for temperature screenings at hospital entrances. Over a 4-week study, these devices were compared with traditional contact thermometers. Key outcomes included an accuracy margin of above or below 0.3 degrees Celsius, enabling effective fever detection. Screening times were reduced from 15 to 20 seconds to just 3 to 5 seconds per person, improving entry throughput by 40%. The non-contact nature eliminated cross-contamination risks, significantly enhancing safety. Challenges such as environmental variability were addressed by using wrist readings for consistency, and for borderline cases, contact thermometers were employed as secondary checks. This hospital-wide adoption led to faster, safer, and more efficient screenings, greatly improving patient and staff flow. Next slide. In conclusion, infrared thermometers have proven to be highly effective for primary screenings due to their speed, safety, and accuracy. They enable rapid fever detection while maintaining hygiene standards. For uncertain or borderline cases, contact thermometers can serve as a reliable secondary measure. This approach ensures a robust and efficient temperature screening system in healthcare environments. Thank you.